Hello and welcome back to the Home Lab. Today we're going to look at a really unusual kind of pendulum called the Wilberforce Pendulum, and by the way, I've managed to fix my lab stool so hopefully that won't be as creaky as it used to be. So let's have a look at the Wilberforce pendulum in action. And what you'll notice is it isn't a normal kind of pendulum that you might recognise that swings from side to side, but in fact what it does is it bobs up and down. And just when you thought it was bobbing up and down and doing nothing else, it seems to bob up and down slightly less and it begins to twist. It begins to get a torsional motion. And you get used to that and you watch the torsional motion. And then after a while, it seems to lose that torsional motion and it starts to bob up and down again. So this is a very unusual kind of pendulum. And what I'm going to do is try and explain to you what it is and how it works. So my Wilberforce pendulum is fairly simple. I've set it up just for the demonstration. Laboratories, when they teach this, have specialist pendulum bobs with little weights that you can screw out sideways on them. But mine's just a spring, some lab weights, a few on top just to get the mass just right. And then I've got a pencil along the bottom so you can easily see the rotation. And as I said, you'll notice that it bobs up and down for quite a while, and then it changes its motion to a torsional twisting motion. And then after another length of time, it goes back to the bobbing up and down motion. And it swaps between these for as long as it still has energy. After a while, it loses energy to the environment and it finally stops. But this is a very strange and unusual kind of motion. So let's see if I can explain exactly what's going on. So this pendulum motion was first discovered by Lionel William Wilberforce, who was at the Cavendish University laboratory at Cambridge, and I believe he actually worked with J.J. Thomson, who was the guy who discovered the electron. He has an interesting family history in that his middle name's William, and William Wilberforce, who came before him in about 1800, I think that was his great-grandfather, was one of the first members of Parliament in the UK who put forth a bill to abolish slavery. So, quite an interesting family background, and Lionel William Wilberforce was a very talented physicist and teacher, and he discovered this pendulum and explained how it worked. So, as you've noticed, the pendulum has two very specific motions. It has a linear translational, or we'll call that bobbing up and down motion, and that's controlled by the mass that's on the spring and also the spring stiffness, the Hookean stiffness. But it has a second motion, which is a twisting or torsional one. I'm reminded by some clocks. I know my grandmother had one on the mantelpiece that have a set of weights that rotate round and then stop and then rotate back the other way to count the seconds and drive the clock mechanism. Well, the pendulum also does that. So it has a torsional motion. And that torsional motion is controlled by a couple of things. It's controlled again by the stiffness, the sort of rotational stiffness of the spring, and the moment of inertia, which is a bit complicated, but it's about what mass is on the spring and how far out that mass is from the centre of rotation. So we're going to look at these two things to see if we can explain what the spring's doing and why the pendulum does what it does. So now you understand that the bobbing up motion is caused by the stiffness of the spring and the mass on the spring. We can use those two values to calculate the natural frequency of oscillation of the spring. So as you pull it down and let go, it oscillates with a particular frequency. But the skill is to set up the pendulum so when you twist it, it also has a frequency of twisting, a sort of torsional frequency, that is similar or almost identical to the frequency of it bobbing up and down. So we've got two motions, one with a frequency that's bobbing up and down, and one with a frequency that's rotating, and they are very similar indeed. So let's now explain why and how it swaps between these two motions. So here goes for the clever bit, and I've noticed that other YouTube videos that deal with this issue often miss this point. The clever thing about the pendulum is that because the bobbing up and down frequency is very, very, very similar to the rotational frequency, if you take those two frequencies away from each other, you get a very, very small number. In the case of my pendulum, I think I get about a 20th of a hertz. And here's the clever bit, that it's a beat frequency. So if you take those two frequencies apart and end up with a 20th of a hertz, that gives you the frequency that it will swap between the up and down translational motion and the rotational motion. And if it's about a 20th of a hertz, that's going to happen once every 20 seconds. So you'll see it bobbing up and down, and then it will move that translational energy into the twisting torsional energy, and then that energy will be fed back after 20 seconds to the linear translational energy again. So two frequencies, take them apart, and you get the beat frequency, the frequency that it swaps between the two different modes of oscillation. So I thought we were done there, but the more observant among you might go, hang on, there's one question you haven't answered. How did it ever get started with swapping between these two forms of oscillation? And that one is not too difficult to explain. If you think about it, when you stretch a spring, the coils uncoil slightly, they twist slightly when you make it longer. So you're putting a torsional force on the spring, which can then be released as it shortens again. Now think of it the other way around. If you were to twist the spring, you might be making it a little bit longer, and then when you twist the spring the other way, you might be making it a little bit shorter. So the effect of the spring stretching causes it to twist, and the effect of the twisting causes the spring to stretch. So those two motions are coupled with each other, and this is why the spring system can swap energy between the linear translational bobbing up and down mode and the twisting torsional mode. So there we go, we're done. I hope you understand what a Wilberforce pendulum is, and you have a better understanding now of how it does what it does. You can obviously change its behaviour by changing the mass on it, the stiffness of the spring, and the position of the mass moving outwards at 90 degrees to the linear motion. But that's much too complicated for this video. So just before I go, I thought I'd tell you a story which was told to me by my physics teacher when I was at school, and it's what got me thinking about the Wilberforce pendulum. So what he said was, he went to a lecture once, and he was sitting in a big lecture hall. Some of the universities have very, very large lecture halls, and on the stage was, it looked like it was hovering, this beautifully polished stainless steel cylinder. So it's sort of rectangle shape when you look at it straight on, but it looked like a massive sort of can, as it were, but very, very shiny, mirrored surface. And it was very difficult to see how it was suspended. It seemed to be sort of hovering there. But what was interesting was the lecturer walked in, and as they walked in to give their lecture, I don't know what the topic was, but to give their lecture, I bet it was oscillations, they just went up to this thing and just pulled it downwards and then let go. Well, it was pretty clear then that it was suspended from the roof, and it was suspended on a very thin wire that was invisible, and there must have been a spring somewhere, because this thing bobbed up and down. That's not exciting. But can you guess what happened next? The lecturer carried on their lecture on oscillations, etc., and it stopped oscillating. Well, of course it would. And then as they carried on lecturing, it started oscillating again. And after a few more moments, it stopped again. And by that stage, of course, it was like some classes I've had, the students in the lecture theatre were not paying attention to the lecturer at all. They were chatting to each other and going, what's going on here? Because, of course, you know, you don't have to be very experienced in physics to know that if something bounces up and down and stops, it's lost that energy, so it can't get going again without another source of energy, and there didn't appear to be one. After a while, the lecturer said, okay, stop. You guys aren't listening. What is it? And they went, it's that thing up there. You know, what's going on? Well, he said, okay, what have you learned? What have you learned about oscillations, and what have you learned about coupled oscillations? What I've got here is a Wilberforce pendulum. Have you got it now? So what was happening was that the very finely suspended steel shiny cylinder on a spring that was out of sight was doing the linear oscillation and then turning that to the rotational one. But because it was so shiny and so clean, you couldn't see the rotational motion. There wasn't anything stuck on it, like lines or whatever, where you could actually see it rotating. So, of course, it was moving all of the time, and it was losing hardly any energy at all during the lecture. And, of course, when it slowed down, or at least the amplitude of the rotational motion became less and less and less, it started to bob up and down again. So I remember that story from, gosh, not quite 40 years ago, but a long time. I've actually never seen it done, and maybe I should set that up at some time. But what a wonderful demonstration, and what a great bit of teaching to get your students to think what's going on with the physics that they've learned. So I do hope you enjoyed the Wilberforce pendulum and you understand a little bit more about it now, and you found that story about the lecturer interesting. I'm going to be making another video soon, and do keep an eye on the channel, or get that press on that bell, because I'm always worried you might miss the new videos coming up. Anyway, always stay right to the end, because I often put some other bits in right at the end. And what we're going to have a look at is Barry on a playground swing behaving not unlike a Wilberforce pendulum. So have a look and see if you can see that happening. Anyway, another video soon, and I look forward to seeing you then.
Oh,